Do you remember your domain and range?
Oh.
Come on, you don't like domain and range? Okay. Grab two different highlighters. I'm going to try to make domain and range a bit more fun. I think you're going to be okay. It's not going away. It's coming back next year, okay? So you need to know your domain and range. So here we go. For domain, I'm going to use pink, and I'm going to use green for range, okay? That's how I'm going to separate it. What is the domain, folks? This should be on your study sheet because sometimes you forget, you mix them up. Domain is what? Refers to all the permissible x values. Okay? So you basically want to see, wait a minute, where's the graph going? Oh, okay, all these x values are acceptable. The set notation is x, e, r. Okay? For parabolas, watch this. Circle is non-contextual graphs. Okay, so no word problems. Okay? And then interval notation would be negative infinity to positive infinity. Okay? Make sure you use squiggly brackets when it's set notation. So there's two different ways of stating the domain and range. I will never make you use one over the other. You can choose, but it could be that I give you the domain on a question and you're going to have to be able to read it. Okay? So what does this mean, folks? XER. You've probably seen it before. X belongs to, this is belongs. It totally makes sense, right? E for belongs, right? I'm just kidding. But that's a notation. That's actually a set notation for saying belong. Yeah, it's a set of. It belongs to. Yeah. Yes. It's a set of. Set of. So x is a set of the real numbers. So it's basically saying x belongs. Let's just write this down. X belongs to the real numbers. That's what that is saying. So real numbers are basically everything. Everything you can possibly think of belongs in the real numbers. So it could be decimals, fractions, right? Roots, it doesn't matter. And the interval notation is saying everything, right? Like the x values, you can go as far back as negative infinity all the way to positive infinity. Everything goes. And think about it this way, folks. What did I tell you about the parabola? It opens up indefinitely in each direction, right? So it would make sense that if you look at the x values, right, this is negative infinity for x. This is positive infinity for x. The same thing if it points down. It still opens up indefinitely. So negative infinity to positive infinity, that is your domain. For anything that isn't a word problem, that's going to be, by default, your domain, folks. It's going to be super easy. If you just remember that, the domain of a parabola is always that. Okay? Let's keep going. Range. What does range? It refers to all permissible y values. Okay? So it's this way. So to summarize it, we're going to have ranges here and here. Right, for these two different graphs. And your domain are the x values that are permissible. Both of these cases, folks, we want to focus in on the vertex. This one would have x and then y of vertex. I want to focus in on the y here. This one has x and the y of vertex. Make sure you add all these pieces that I'm adding here, highlighting and everything. So domain, in a sense, is saying what values are acceptable for this parabola for it to exist, and the answer is all of the x values. If you look at the range here, folks, look up on the screen. Are all y values permissible in this case? No, it doesn't go below this point, right? If it's pointing up. And when it's pointing down, it only goes up to a certain point, but then it only goes down from there, right? So it's not all of them permissible. That's how domain and range will be different in this case. So when you have one that's pointing up, okay, I will actually write this down, points up. When I have something like this, the set notation would be as follows. You have to use squiggly brackets. You would say only y values that are greater than or equal to the y of the vertex are acceptable in this case. That's the set notation. This is the one that most students tend to prefer, the one that's interval, the interval notation. Saying the same thing, you would say that only values that start at the y of the vertex and go all the way up to, watch this, the arrow, like if you think of the arms expanding upwards indefinitely, you would have to conclude that infinity, this would keep on going forever. The y values, correct? What kind of bracket should come in here? Round or square? I don't know if you remember that from last year. If there's arrowheads on the ends, that means that you're not like there is no end to this. So you have to go round brackets. Very important. What do square brackets represent? Square brackets means includes this value itself. So in this case, we would go from here, include it, all the way up to infinity. Okay? So whenever there's infinity, never, right? I will make a note later on. Always use round brackets whenever there's infinity. Okay? When it points down, you might want to add this to your study sheet later on. This one right here helps a lot of students. Okay? When it points down and you have set notation, it's going to be y is less than or equal to the y of the vertex. And you might have to watch this again later on. You might have to. And think about it. Only y values that are less than or equal to the vertex point right here, the y value of the vertex, only points that are less than that are acceptable. Otherwise, anything above it, the graph no longer exists up here. Okay? If you want to write it in interval notation, you're going to do it the other way. You're going to go from negative infinity, round bracket, all the way up to the y of the vertex. So the vertex is going to be your go-to here to figure out I'll say this here. Note, you need the vertex to state range. If you do not know the vertex, you're not going to be able to state the range of the function. Okay. Also, note number 2, smallest first, largest second. Always. So if this is a range that you're stating, because later on when we do word problems, folks, very few instances with infinities if there's word problems. We're not going to have a lot of infinities show up, so you're actually going to have square brackets a lot. So example, if you ever do this to me, you should automatically know something is wrong with that. You always want the smallest first and largest second. So you should have this, right? So this gets an X and this gets a check mark like that. Just It's little things like that that you should be catching as you go along. Third note, oh my goodness, right? Round brackets when infinity appears, okay? I don't want to see any square brackets around the infinity symbol, okay? Because you cannot include infinity because it's not a single number. It just keeps going, okay? I started counting when I was like 5, and I'm still getting closer to infinity, right? I'm working on it. Yeah, I'm not going to get there. That's a good one with my kids. It's like, what's the biggest number you can think of? A gazillion billion, right? And then you tell them, what about a gazillion billion plus 1? Oh, what? Right? So you try to introduce the infinity concept to them. All right, let's try some questions here. We're going to assume there are arrowheads. This is page 8. We're going to assume there are some arrowheads here on these parabolas, okay? State the domain and range of the following. So we're going to do domain in set notation and interval. Then we're going to state the range in both formats, okay? So here we go. This one, I know the vertex. This is the vertex right here. Very important for us. So for domain, set notation, this is a freebie, okay? It's not a word problem. This is how I do squiggly brackets. I literally just do squiggle, 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 squiggle. That's good enough, okay? Just make sure it's not a square bracket or a round bracket, because then in the province's eyes, you're going to get a -1/2. So just make sure it's a squiggle. Interval notation, it's just your interval is basically you're stating the two values in which this function exists. And make sure you use round brackets for infinities. Quick note, in intro, they told you that brackets are not important when it's interval, right? I feel like that's what they told you. It is important and applied. Like you have to do brackets, and we've been telling teachers to make sure they teach it that way in the intro. So make sure that, so this is a freebie in my opinion. It's the range that is a bit more complicated. So for set notation, watch this, okay? What did I use for range? I used green. I'm gonna go to the y-axis, and I'm gonna say it starts here, and then it goes down, right? This parabola starts up there and goes down, okay? So, y is less than or equal to, in this case, 2.749. And make sure you do the squiggly brackets. Okay? So you're saying only y values that are either equal to 2.79 or less make this function happen, okay, or acceptable in this case. For interval, how would you do that? I don't know, Mr. Dixon. I know this keeps going down, so there's definitely a negative infinity there somewhere. And it goes all the way up to what? 2.749, right? Is this acceptable? Is negative infinity smaller than 2.749? And the answer is yes. So we don't have to flip this in any way. We can just state it like that. So I'm going to go negative infinity, round bracket, all the way to 2.749, square bracket. So the number gets a square bracket, the infinity never does, okay? Try this one right now on your own. State the domain, freebie. Domain is freebie. You can close your eyes and copy paste. It's the range that you need to watch out for. So try that before I continue. Got my domain, I got my half mark, okay? The range, y is, it's pointing up, correct? So sometimes I ask students, go to the vertex, match it to the y-axis, and you know this is going up, okay? So it's gonna be y is greater than or equal to, I need to come up with the coordinates of this. This is 1, 5, right? Based on this scale here. So it's greater than or equal to 5 is this. 5, 1. Nothing happened, nothing happened. It's already confusing and I'm just adding to that confusion, right? This is going to be from 1 all the way to positive infinity. So in this case, 1 is smaller, infinity is larger, positive infinity. There's a round bracket here, square bracket there. That's what it looks like. Okay, so that's domain and range. We're going to continue. It's not going anywhere. So now I want you to go to page 9. Okay? We're going to graph this thing. Okay? So pay attention. The first thing that we're going to do is things that we can do without a calculator. You're listening, right? I don't want you to just blindly trust that calculator. I want you to understand what you're doing. So before we start, what form is this? General. Okay? Yes. No brackets. Which way is this opening? This is the leading coefficient right here, correct? A is negative, so this is going to be down. Okay. You know what? I can't tell you how many times students just blindly type this in and it points up and they completely miss it. They just keep going, but you should know it's down. So you made a mistake when you typed it in. What's the width? It's wide because it's between, A is between 0 and 1. So we can do all of these things without even using our calculators. Y-intercept, what is it? Negative 200. However, I will tell you what the steps would be using a calculator right here. Ready? All you would have to do is second, trace, value, x is equal to 0. That's all you do there. Highlight that part because you're going to need it for the other ones, most likely. And if you want to add that to your study sheet, that's how you get your y-intercept, that's probably a good idea. What's the vertex? Can we figure it out just by looking at this one? And the answer is no. Axis of symmetry, what do we need for it? We need the vertex. Equation of min or max, we need the vertex. X-intercepts, we can't do the rest. That's all. It stops there. So let's type in this equation into our calculator. Make sure you do that, okay? Y equals, I'm going to go negative 0.5 x squared plus 25x minus 200. This one isn't going to show, it could be that it doesn't show up on your screen, and I kind of want that to happen, okay? That's mean, right? No, it's like, it's going to happen, so you're going to have to get used to it. So hit enter, and then hit graph. None of the plots should be highlighted, all right, guys? None of them. Hit graph. Whoa, you see a little bit, right? What happened there? Well, where's my y-intercept? It's at negative 200, correct? So it's like, if this is my y-axis, it's like way down here somewhere. Way, way, way down here. Let's go find it. And this is where I'm going to introduce the window to you. Okay, so you got to press the window, press that button, and don't be too overwhelmed. The only 4 entries I want you to think of is x min, x max, right? It shows you 10 to the left, 10 to the right. That's what min and max would represent. And y min, y max. This is the lowest you're seeing on your screen, and y max is up here. What should we change here to see the negative 200? y min. I'm going to change it to negative 250. You got to press negative, not minus. Okay, negative, like the negative in brackets. And let's hit graph again. Oh, now you see more, don't you? And does it make sense that it goes this way? Yeah, because we know that it opens down, right? We know that. So you just have to put the puzzle together. What else should we change, folks? If I go to my window, you see how it goes up and it goes further to the right? Y max is up here, X max is here. So let's go to our window, change the X max, and you're like, Mr. Dirksen, what should I change it to? That's where you come in. I usually go up, like I'll go 50 right now. I'll just go 50 for my X max. And my Y max, I'm also going to go 50. So I just play around with numbers. Hit graph. Now I see more, right? Now I see the whole thing. I still don't see the vertex, which is up here, right? What do I need to change on my window? Y max, that's correct. What should I change it to? I'm just going to go 100. 150? I'm just going to pretend I didn't hear that. I'm going to hit graph. It's still not good enough. One more time. Window. There it is. That is an acceptable graph. Now you have a window that works. So, before I continue, I'm going to ask you to put your calculator to the side like that, and I'm just going to down here tell you for window, okay, make a little screen. This is your calculator screen. Up here is what we call the Y max boundary. Down here is what we call the Y min boundary. You will literally see between the Y min and Y max as per your calculator. And what do you think? Where is X min going to go? Yes, X min goes left, X max goes right. Okay? Right. Okay, now that we have the graph, let's find the vertex. Did you copy that? I hope so. Let's find the vertex now. And I will first give you the keystrokes. Ready? You're going to go second, trace. Let's press the buttons first together. Go ahead and press second, trace. Which one is this now? Is it a min or a max based on our situation? It's a max, right? So we have to select max. So I will tell you this, min / max. But in this case, we have to select max. So go ahead and select maximum, hit enter. You have to follow what I'm doing, okay? I'm going to zoom into my screen for a little bit here. You have a pencil, right? Or something? Where's the vertex right now? It's right there, correct? What is the calculator asking you for? There's a question down here. Left boundary. It's saying, give me a point that is to the left of the vertex. I happen to be there right now. I'm to the left of the vertex. You can use your arrowheads, go left if you want, or right, but let's say my cursor was somewhere over here at the very beginning, because it is random. If it says left boundary, it wants you to go to the left of the vertex, somewhere, anywhere, it doesn't matter. This is like going overkill. You could have stopped way up there. You hit enter at that point. Just hit enter once. As soon as you hit enter, what is it going to ask you next? Give me a point to the right. What's the right boundary? So you're going to go with your arrow sideways and go to the right. Okay? Anywhere to the right and hit enter again. Now you've told the calculator, I know that the vertex is somewhere between here and here, go ahead and find it. Every time it says guess, it's just waiting for you to start the process. So just hit enter. Every time it says guess, you just hit enter. And it tells you exactly what the vertex is. What is it? 24.999. That's 25, right? Round it. We're always going to round to 2 decimals. 25, 112.5. So write that down. I did write it down right there. Okay, keep going. How do we get our axis of symmetry in our equation of min and max? I'm glad you asked because it's right here. X is equal to 25 is my axis of symmetry. Remember, it's an imaginary vertical line that cuts through the parabola. Yeah, go ahead. It cuts it in half, right? The equation of the max in this case is a horizontal line that goes through the vertex. We're going to use this. This is 112.5. So you've got those two straight from the vertex. Next, I need to find my x-intercepts. How do we find that? Here's the keystrokes, folks. You ready? y2 is equal to 0. Then you're going to go second, trace, intersect. And you're going to hit enter 3 times. So grab your calculator. How do you get to y2? What would you press? You press y equals, correct? Then you go to y2 and let that equal to 0. Go to y2 and just type in 0. And when you hit graph, that's going to be a horizontal line going right along the x-axis, right? If you don't believe me, hit graph. You should see that red line appear. Okay. How many x-intercepts do we have here? 2, correct? We'll find both of them. So you're going to go second, trace, intersect, which is option number 5. And this is a little easier, folks. You got to go with a cursor. So if you want to find this one, ready? You just go a little closer to it, as close as possible. That is good enough. And then you just press enter 3 times. Enter, enter, enter. And you get 10, 0. Okay? I got 10, 0 on my screen there. And you know you used intersection, so that's good. As soon as you make a mistake, you press some button by mistake, you got to repeat the process. You got to go second, trace, intersect, or else you'll not get it. Okay? 10, 0 is the first one. And what's the second one? This one right here. Second, trace, 5. I'm now going to go over to that one. Just press and hold the side arrow to the right. That's close enough. Enter how many times? 3 times. Enter, enter, enter. And you get 40, 0. Okay? We'll do the domain and range a little later. Let's sketch this thing. We have everything we need to sketch it. Here are the important points. Let me highlight that. I'm going to use pink. Okay? You always want your x-intercepts and the y-intercept and the vertex. Those are the three pieces that must accompany a good graph. So your intercepts, right? We consider the x and y-intercepts together are called intercepts altogether, and the vertex. So if you have the intercept and the vertex, then you're good to go. Okay? Okay. Let's graph it. Let's graphing time. I'm gonna ask you to do a lot of this graphing. Okay? So first and foremost, we're gonna make sure our axes have arrowheads. We're gonna make sure they're called something, so we label y and x. Okay? Then we're gonna come up with a scale that works for us. Okay, this is important. I start with the vertex. Where's the vertex? 25, 112. So let's see what works. If I were to go by fives, 5, 10, 15, 20, 25, that wouldn't work because then I'm out of bounds. So what I'm going to make every 5 boxes worth 10. Okay? And that is an appropriate scale. That's going to make this work. And you will realize soon enough what works, what doesn't work. So I'm going up by 10 here. And I'm going to say the same thing on the negative side. There we go. So we have a scale of 10 here. Every fifth box is 10. So technically every single box is worth 2, right? 2, that's how you do it. What about the y-axis? The y-axis can have a different scale, folks. It actually can. So let's see what we need to fit in there. Where's the y-intercept? 0, negative 200, correct? If we went up by 10, that would just not work based on what I have here. I'm going to use 100 instead. I'm going to go negative 100, negative 200, negative 300, and so forth. Could 50 have worked? Probably. 50 probably would have worked as well. I don't care as long as you're consistent. So this would be 100 here, 200 there. You cannot change it. Once it's 100, you need to keep it the same. What is the center here called? It's called the origin. It's 0, 0, okay? Just remember that. Now we're ready to plot. I'm going to put my vertex down. 25, 112 is right about there. Approximately is good enough. That is good enough. 0, 200, that goes right here. 0, 200 is right there. I'm going to make a big dot there so it sticks out. And my x-intercepts, if they are there, right? So x-intercept is 10, 0, so that'll be right there. And 40, 0 is right there. You should see the parabola at this point, that it's appearing there. I have all my intercepts, and I have the vertex. Perfect graph. Now you have to be careful. I would start at the vertex and slowly try to go out a little bit, and then you curve in. Okay? And you go like this, and you can actually go off the graph, out of bounds if you want to in this case, because it's not a word problem. You go back to your vertex. You do the same. Go out a little bit to the side, then you curve in. And try to make it symmetric if possible. The only thing that's missing here is the equation itself. So this would be y is equal to negative 0.5 x squared plus 25x minus 200. Voila, right? I'm just going to do the domain and range. I'm going to ask you to do homework is pages 10 to 11. So 2 of these graphs, that's all I'm asking you to do to the best of your ability. What's the domain and range here? Hold on. We'll just go x is all real numbers. And my range, it'll be y is less than or equal to 112.5. Or, if you like interval notation, it would be negative infinity, negative infinity all the way to 112.5. Square bracket, round bracket. Okay, both of them are acceptable. I know it's a little overwhelming. Listen to this part. Will you get into a problem with the graphing calculator when you're trying to do this? I'm willing to I'm willing to put down $100 that you're gonna be like, why is this not working? But that's part of the process. When you come back the next day, you're gonna be like, oh, okay, now I know why wasn't working, right? So you just need to still try it no matter what. Thank you guys.